last regression assignment which you have given.
Right.
So in that few variable have three values.
Are they predictor or target?
Predictor.
Yeah. So you need to be careful. Here we are deciding linear or logistic regression based on the target variable, right? So predictor variables, you can have any number of classes, or it can be categorical, or it can be numerical anytime. In the target, you can have multiple classes as well. That will be multi-class classification. We will reach there as well. As of now, I'm talking about binary classification, but we will also discuss about multi-class classification. It is possible that in the target variable, the output can be class A or class 1 or class 2 or class 3 or class 4 or class 5 or even class 10. We will do an example where the output can be one of the 10 classes in our future, one of the course, one of the topics, where the output can take one of the 10 classes as the output. So that also possible. But here we just got introduced to classification where there are only 1 or 0 is the output.
So beyond two also it's possible, right?
Possible.
For target.
Yes. So this is binary classification. This is multi-class classification. Possible. Very much possible. Multi-class classification is also possible, and there are so many applications for that as well. That is question number one. Can there be multi-class classification? Question number two is sometimes the data is neither a straight line, neither a straight line that your linear regression works, nor the data is not like this. The data is neither like this. It's not even like this, where I can simply build y equal to e power beta naught plus beta 1x divided by 1 plus e power beta naught plus beta 1x. This is also not my data. My data is like this actually. My data somewhat looks like this. Imagine. Imagine my data is like this and I cannot draw and see. I have multiple dimensions. Somehow I know somehow that my data is like this. If I build a straight line, then it will fail because this is not going through full data. Maybe even if I build here, only a part of it will be used. If I build an S-curve, then also it will fail. Can you tell me what does this look like? Somebody who has mathematical background will be able to tell me this looks like something else. Hey, quadratic. Can you tell me equation of quadratic? Can you tell me equation of quadratic? Quadratic, parabola, these are all correct. Cool. Good. Tell me, have we seen any of that? Check this, a part of the quadratic, isn't it? This matches with our side of the quadratic, isn't it? This is full quadratic, but in our range, this is the quadratic that matches. Y equal to, almost there. Y equal to x square plus ax square plus bx plus c. I like that one. Y equal to, since we don't use a's, b's and c's, so we use like beta naught x1 square, beta naught plus beta 1 x1 square plus beta 2 x plus c, something like that. One only. You have only one variable, but you take the square term as well. Then you will be able to bend that curve like this. What happens? When do you arrive at it? How do you arrive at it? Later on in one of the sessions, we are going to discuss that. But let me give you a hint right away. What if you build this line to this one? You did not add the polynomial term. You did not add the square term. You have directly gone ahead with the straight line and you built a model like this. If you build a model like this for this data, how do you get to know there is something wrong with this model? How do you get to know? Not by drawing it. What is the measure that will hint you? What is the measure that will tell you, hey, this model is not good? Which measure will tell you that? Tell me. Which measure is like you have gone ahead with linear regression? Your R square for this model, will it be high or low for this model if you build it? your R square value will be low. Later on, we are going to discuss something called feature engineering. So X is a feature, we engineer that feature. Maybe we are considering sometimes square root term, sometimes log transformation, sometimes square term we can add. Then in the feature engineering, we will try to see whether when we can tweak the original data of X and improve the R square value, and we will see once we are done with everything else from the original data, can we do some feature engineering? That means tweaking the variables original data, extracting the hidden pattern to increase the model accuracy is called feature engineering. We have a dedicated session for feature engineering tips and tricks. There we will learn if there is any other pattern that is beyond the standard patterns. The standard patterns we are learning because most of the times these work. Even beyond this is the situation, what to do. That also we are going to discuss. Everybody understood what I'm trying to say here? X is given to you. With X, you can build the direct model, but X square term you will add in feature engineering session or feature engineering tips and tricks when you're trying. Then you will add X square term, or maybe you will add log X also. You will check because you don't know whether the real data how it is. You will try log X, you'll try e power X, you'll try square root of X, you may try 1 by X. That may work some cases. That final transformation of that variable sometimes works like a charm. Is that clear, everyone? The question and the answer. What if it is neither this curve nor this curve? What if it is like this? How to do it? In fact, later on, there is one magic machine learning algorithm that will fit for any data, any pattern, any data, any pattern. It will adjust on its own and give you the final model. It's a magic machine learning model, magic ML model that will take any data, you have any pattern, it will automatically adjust. It's such a flexible model. It will automatically adjust, add all these terms on its own and give you the model. Do you know the name of that magic machine learning model that can fit for any data and any pattern? That algorithm name is artificial neural networks, which we are going to discuss little later. As of now, we are kind of working in a very constrained scenario. When the data is in a particular format, then only linear regression works. When the data is in a particular format, then only logistization works. Slowly, one by one, we'll increase the complexity and reach to the complex models later on.